What? What? What?
I know, it's crazy.
What?
Doesn't open until 11.
And first get better and get second one. Like, that's
I mean, I got it last time when I had.
Sophia, just skip.
I don't know if we have to do the high ground.
Yeah, honestly, just skip.
Just skip.
Just skip.
Yeah, that's what I would do. I would just skip too.
Yeah, just skip.
Go with it.
Credit
Go
to
with
Mr.
it.
Brand.
Go with it.
Mr.
Yeah.
Brand, that way, if you get,
Go ahead.
if you get in trouble, you can
Hey.
blame Mr. Brand.
Do that. Yeah, go ahead. That and a grain of salt will get you some tasty fries. So, all right.
You really think the lake?
All right, ladies and gentlemen, here we go. Get to work on this problem. Jennifer. I didn't say it was.
What is on the quiz? Just molarity, that's it?
Yeah. Yeah.
Olivia. Olivia.
Yeah.
Thank you.
Yeah.
What?
What do you mean you heard about it? You actually heard about it?
That's just hard drop. That's just hard drop.
Man, it would have.
Well, I think you would create that next
It reminds me.
I don't.
Yeah.
I don't believe in they having a meat, so I'm not even gonna say.
Austin, are you good?
Heck no, I don't have a 3.5.
Yeah. Wait, Mr. Brand, if any, oh, never mind. Take that.
What?
I was gonna say, if it's on the test and it gives us like sulfuric acid, are you gonna tell us what the formula is?
I will not. Nope.
It's P. Sulfuric acid, sulfur. Yeah, it would just be Wait, Mister,
Yes.
is sulfuric the sulfur or is it sulfate?
Remember-
Since it ends in ic, it's binary, which means it's just sulfur.
No, be careful. Because it does not begin with hydro.
Oh,
It is not binary, and therefore it is named off of a polyatomic.
even though it ends in ic.
Correct, because there is hydrosulfuric, sulfuric, and hydrosulfurous. Or not, I'm sorry. Hydrosulfuric, sulfuric, sulfurous acid. If it does not begin with hydro, it isn't a polyatomic is involved. If it ends in ic, that comes from an 8 polyatomic, so sulfate. If it is an OUS acid, that comes from an ITE ending on the polyatomic. So sulfuric acid comes from sulfate, and then you put hydrogen with it.
But if it started with hydro, it
Then-
would be.
Then
a
you are
binary.
correct. Then it's a
Okay.
binary, only 2 elements, hydrogen and 1 other element. Yes. Yes.
So it would be SO3 instead of SO4.
No. If it were sulfurous acid, it would be SO3.
But this is says I don't know where he's getting the hydrogen gas.
Correct. And the 8 polyatomic sulfate is SO4.
Yeah, I was thinking of.
So where are you getting the hydrogen gas from?
Because all
Well,
acids have
all
hydrogen.
acids still have hydrogen with them.
Oh, so
Does
you
it matter
always
where you
add
put it
base
then?
to it?
Does it has to be at the front?
Well, it has to in the acid.
Yeah.
In the acid, yes, it begins with hydrogen. Hydrogen is acting like a metal. Now, when you write your compounds on the product side, it doesn't matter which one you write first. Okay?
So when you make when you do the acid, do you have to like make it like the zero where you like bring the charge over?
Yep.
Yeah.
Yep. That's what I mean when I say it's acting like a metal. Yes.
So then are the iron and the sulfur gonna be smaller?
Iron and hydrogen. Hydrogen is acting like a metal in that acid.
Oh.
Hydrogen is acting like a +1 metal. So
Okay.
iron is going to change places with the hydrogen. That's how you get the hydrogen gas at the end.
Oh. Wait, what's the charge of iron? Oh, +3, sorry.
And I have to tell you this in the problem, otherwise you couldn't write a compound for it.
Oh yeah, that's the
And then it says how many liters of hydrogen gas would be created, which means that it's just gonna
Can
be
you come check
hydrogen by
my
itself.
like where you do the little cable underneath it?
Sure.
So it's gonna be,
So I feel like I made it too big.
and then
Because I had to
Nope, that's not here.
I wanna do actual compound and then do
Well,
quiz today.
Yeah, and a lot of times the only way to get
then you just switch it. So you put it
them
wait,
even
I
sometimes
I might
six, you have to create a squad.
If I get one wrong,
Yeah,
I'll
that's
do
like,
it.
you have to get to six. That's not
because
that.
before it was the
And
iron
these
that was by
numbers get
itself,
into
and
like
now it's
sixes.
Yeah.
That's a fairly large number that
I
it's
realized
possible.
class were like,
but
it's
normally they
okay,
balance
it's
a little bit.
okay.
So what you got
Because in this situation, the metals
Okay, so what else
are
is
in this
big?
one,
Um,
and then you just do one stage too.
oh, why?
And by the way, don't put a positive two there.
Oh,
Because those are two separate things. Those are the two different reactants that you begin with. Which means this is setting up to be a single replacement reaction. So you now write the two products.
I took Isaiah and Josiah in the same play.
Okay? One of them is hydrogen gas. You have to figure out what the other one is.
Do you do? So like, I'm just confused. What do I start? Because I have the equation, but then like we're looking
Okay,
for the
so, okay, but what do you get? So always begin with what you're given and do what to it?
make it all base.
Okay, get it in the mold. Then what's the second step? Coloration. Get out into the unit that it wants. What unit does it want?
I can do, so do we have to worry about the?
They have you like this?
Well, it's a gas.
You slap my.
They're giving you pressure and temperature.
That
Why?
Oh, no, for the S, there's 4 of the oxygen. Ignore the 2 in front of the FE, because we're trying to balance it right now, but is the rest of that right?
Yes, it is. Okay.
But, and then to balance it, we would have to put, there's, on this side, there's 1 S
I don't know
and
if
4
that's
O, and
concern,
then
it's like
there's
they're
3 S as well. So we put the 3 in front of the
So-
H too.
Yep.
Okay.
By the way, because it's SO4 on one side and it's SO4 on the other,
We can just do it in
you
S.
could leave it together as SO4 and how many groups are on one side, how many groups are on the other. It keeps your numbers a little bit smaller too. You could have like 3 times 4 to get 12 oxygen. But however you need to do it to get what you need to is fine.
Like, I was only there to see like people's faces.
It's only 10 minutes.
Like I thought Stacey would do that.
Yeah, got you.
But
So
actually,
you
there
were
was
forming
no
for
special
sulfuric
case.
acid.
So
It was
because
just
on this
blood.
side we have
Oh.
3 sulfurs and 12, and in order to get down the other side we have
It was
1
like
and
blood.
3. And so since this is all one compound, it has to go in front of hydrogen
So
too.
then that gives us 3
And there was a point where Greta said this is
Oh,
too.
hang on one second.
And then you
Oh, no,
add
no, no.
like
A rat? A rat, yeah. And she like untied it and I was like, oh my god.
Yeah,
And
so we
then-
don't have to do it. We don't have to do it with this one because for this one
What
it's
about so
already
much
balanced
blood?
out. We have 2 and 2.
Okay, please listen.
We have
Just so that we get something straight.
3 and 12 already. But we just have to pour it out into this one.
Hydrosulfuric acid is a binary acid. Why is it binary? Because of the prefix hydro at the start. That means this acid only contains 2 elements. Hydrogen has to be one of them because all acids contain hydrogen. So hydrosulfuric would be hydrogen and sulfur. Sulfur is a -2 charge. Hydrogen is a +1. So your formula would be H2S aqueous. That is a binary acid. Okay? Now, there is sulfuric acid. This is a ternary acid. Ternary acids are based off of a polyatomic. And the way it works is an ATE ending on a polyatomic becomes an ic acid. An ITE ending on a polyatomic becomes an OUS acid. So sulfuric comes from sulfate. Sulfate is SO4, -2 charge. We still put it with hydrogen, which is a +1, and we get H2SO4 aqueous. Now, if we were given sulfurous acid, now sulfurous comes from sulfite, ITE ending, which is SO3 -2 charge. We would still put it with hydrogen, which is a plus charge, and we would get H2SO3 aqueous. Hydrosulfuric, sulfuric, sulfurous. Okay? So that is the naming of our acids. All right? So you are working with sulfuric acid in this problem. So this has to be the formula that you choose. Keep working, ladies and gentlemen. We'll give you about another 2-3 minutes, and then we will go through it. Yes, I can. Thank you. Okay. Sophia, you got a question?
Yes, so I got, but then you said you'd have to do the PVRT, so I don't include it, so.
You can't put it into liters in the format that you have. Why? Because PV equals NRT is not a formula where it has this over this,
But then we
like
have to do
converting
the,
it from moles to grams
so this is
or grams to
28
moles.
into moles.
So I stop here, I get my answer in moles. I then put that answer into PV equals NRT.
Oh, okay.
Only because it would be hard to put that, to continue that into the equation. It could be done, but it's difficult to do. So I take that moles of gas that I have created and then plug that into the PV equals NRT formula using the pressure I'm given, the temperature I'm given,
Yeah.
solving for volume, given the number of moles. Now all I need to do is remember my R value. Okay?
Yeah, which is just.
No, you just use Epi. Do not worry about the two in front of it. The two in front of it gets taken care of when we get to our ratios. Okay? So we don't want to ever have to worry about, well, what if there's a two in front, what if there's a three in front? We take care of those 2s and 3s that are in front in our balanced equation when we do the ratio. Okay?
And then since we're looking for this, our molar ratio is gonna be.
Oh wait, we put what we're going into on top, right?
What we're going into is on top, what we are in is on the bottom.
No, it would just be 3 because the 3 right here is on the top.
No, don't use the T.
Wait, look, this is.
I just put molar.
Oh, that's the ratio.
Wait,
Wouldn't it be 6 because we the formula ever changed from 5? It changed it from 6 to 8. Or is it just the one?
No, yeah, I
It's just
know
the
that.
one.
I'm talking about like after.
Yeah.
What's that?
So there's only.
Correct.
You
Yes.
guys do like both, so like.
It's-
so like, we're gonna change that to
And then we turn this into
Well,
meters, right?
Once you get the moles of copper nitrate based on this volume and this molarity, then you can convert that into grams.
Just temporary. So since it's looking for how many liters at a certain like PSI temperature and stuff, do we put that into liters first and then put the liters into that, or?
Liters into what?
Well, what are you going to be given? Okay, you've taken what you've given and gotten it into moles, right?
And then we did the molar ratio too.
Okay,
so
what are you in, what are you in after the molar ratio?
Hydrogen.
Okay, so how are you going to use moles of hydrogen,
Oh.
a pressure, and a temperature to find a volume?
Okay, I see what you mean. Okay. Thank you.
So how you gonna do it?
You use the beginner, but
Yes.
you don't solve for, like, you don't turn that, like, what we have into volume, or put it into the beginner, you don't solve volume that way.
Correct.
Okay.
Yes. Now,
I put chicken at 7.
if we had started with a gas,
Yeah.
I would have given you pressure, volume, and temperature, so that you could find the number of moles, and then use the ratio afterwards. But when we're coming out in a gas, and we're looking for the volume, you're gonna have the number of moles, I still have to give you a pressure and a temperature, and now you can use PV equals nRT to solve it.
Right at 7.
Does that make sense?
I'm still working. I'm still working. I'm not having enough time to think, and I'm gonna do it. And also, I have to leave by 30. And she's like,
Rocio, any questions?
We're solving for
I need to sign it perfectly, and you're kind of messing me up here. You know what I mean? I thought that was fine. Hey.
That's right, right?
Yep. And then our R value, PSI is
Yes.
Okay, I'm just.
292.8.
Oh, yeah,
Okay,
Times this and divide it by 5, right?
hang on. After I go through this problem, I will explain what you're doing wrong. It's a common mistake that some people are making, and I will show you, okay?
All right. So let's take a look at what we've got here, ladies and gentlemen. Okay? So, for this problem, again, we begin by writing a balanced chemical equation. I started with Fe metal, iron metal. Nothing with it alone. With sulfuric acid, H2SO4 aqueous. I'm going to create hydrogen gas. It says how much hydrogen gas. And then I am going to create iron 3 sulfate, which means this iron has a +3 charge, the sulfate has a -2, Fe2, SO4 in parentheses 3. I then balance this by putting a 3 in front here. That means I have to put a 3 in front here. And then I have 2 irons over here, so I put a 2 in front here. This is a typical balancing of an equation that you may have to do. Now, I didn't show the work, but there are multiple ways of balancing an equation. The one thing I would tell you with this problem, again, you can leave the SO4 together instead of breaking them up at the bottom. It doesn't matter either way. But I would have started with either the SO4 group or the oxygen only because it's going to be one of the harder ones to balance. And this is a lone element, and this is a lone element. I can put whatever number I want in front of them, even that half trick. I could do that if I needed to. I could if I needed to. In other words, if I had an odd number of hydrogens over here, I could put a 0.5 in here to get to an odd number of hydrogens, and then I could go back and double everything. That trick that I showed you earlier, sometimes you may have to do that. It doesn't need to be done here, but by saving this and this for the end, I can put whatever numbers I want in front of them. Okay? Here it's tied up in a compound, so since I need more of this SO4, that's the place to begin, at least where I would. It isn't the only way to begin it, but that's what I would do. Okay? So now we take what we're given, 67.8 grams of iron. We get it into moles using 1 mole over the formula mass. Formula mass is what iron would be off of the periodic table. Go ahead.
Why did you put down that you're looking for milliliters?
Well, I'm sorry. I changed the problem after I wrote it. That's my bad. Because when I wrote it, I worked my answer out. And when I realized my answer was going to be 42.2 liters, there's no way in hell I would ever ask you to put that in milliliters. It's just too large a number. It made no sense. So I'm sorry. I went back and I realized that it was going to do that. So then I changed from milliliters to liters. Okay? And I just didn't update it here because I had already done the calculation. Okay? So you're right, though. That should be just liters. I can't cross it off because it's whatever. After you do the getting into moles, we do a ratio step. And again, Olivia asked a good question. Well, what about the 2 in front here? Do I need to double something because of it? And the answer is no. These numbers in front here get taken care of by this one step right here. This ratio step takes care of all of the coefficients that are in your problem because what we're going to goes on the top, what we're in goes on the bottom. And what it means is that for every 1 mole of this that we have, we are going to make 1.5 moles of hydrogen for it. A 3 to 2 would be 1.5 times more. But we take care of it in this step. Don't have to worry about it. I don't want you changing what we've already taught you, which is how do you get from grams to moles or moles to grams? We use formula mass. We're not going to go and start doubling formula masses or tripling it because of numbers that are out in front here. That all gets taken care of right here. The next thing. I stopped the problem here because I get the number of moles of hydrogen gas. And given the information that I have, how many liters of hydrogen gas will be created at this pressure and this temperature? They're talking about a gas. I'm giving you these numbers because you're going to have to use PV equals nRT. And PV equals nRT is not an easy this over this calculation. So I stop here, I get my moles. I'm now going to put it into the PV equals nRT formula so that I can then solve for liters here. And that's what I've done. Here's my pressure. Liters is what I'm looking for. Here's the moles from here. Here's my R value from what I gave you before. Here's the temperature converted into Kelvin. I solve for liters. I get my answer here, ladies and gentlemen. Okay? Now, again, I mentioned this to KP. The problem might begin by giving you information about a gas at the start of the reaction. If they do that, they are going to not only give you a pressure and a temperature, but they will give you the volume of the gas. Because now we can use PV equals nRT to, instead of solving for liters, to solve for moles. And then we use the ratio step afterwards. So what we're finding is, I can begin with grams, I can end with grams. I can begin with volume of a gas, I can end with volume of a gas. Okay? And there's only one other one, which is molarity, which we'll either show you today or tomorrow, depending on how much time. Questions on this? Okay. Now, again, got to ask this question by Aiden, so I would like to go over this with you, ladies and gentlemen. Aiden, what problem were we talking about? Number 8? All right, I'm getting to the molarity worksheet here, ladies and gentlemen, the one in the packet that I gave you. and we're going to take a look at number 8. So here's the molarity worksheet. We're getting to problem number 8 here, ladies and gentlemen. Okay? Problem number 8 on the molarity worksheet. All right. Now, again, you have to be very careful, ladies and gentlemen, of the difference between a multiplication sign and using unit cancellation and an equal sign, meaning this side of the reaction is equal to this side of the reaction. Okay? You need to be careful with this, and sometimes we are getting confused, and then you look at me and go, well, why did you do that math? Well, because there's only one correct way to do math, ladies and gentlemen. There are multiple ways of doing problems, and I don't care how you go about doing them as long as your math is correct. So, let's take a look at this problem, and I'm going to show you a couple of different ways of doing it. You can do whichever way you wish, okay? So, first thing, how many grams of copper nitrate? Copper 2 nitrate specifically, is Cu plus 2. Nitrate is NO3 minus 1. So that is CuNO3 2. That is what the compound is. Okay? Now, it wants to know how many grams are in 55.6 liters of 0.050 molar solution. So, 2 ways to do this, ladies and gentlemen. Actually, probably even more than that, but I'm going to show you 2 ways. One, I'm going to show you the way I would do it first. I am going from liters to grams, which really means I'm going to moles first. And then I'm going to go from moles to grams. Questions on that? So what I'm going to do is I'm going to take my 55.6 liters and I'm going to multiply it by 0.05 moles of copper 2 nitrate is really this, ladies and gentlemen. It is really 0.050 moles of copper nitrate per 1 liter. So that's the way I'm going to put it in here. Are you physically capable?
I think so.
Okay, go. Liters and liters cancel out. I am left with moles of copper nitrate. Can someone please take 55.6 times 0.050? Should be about 2.78.
Yeah.
Thank you. Sorry to cut you off, Ava. Thank you. 2.78 moles. Now we got to get this into grams. We'll do that in a minute. Here's the other way you could have done this, ladies and gentlemen. 0.050 molar is equal to X number of moles of copper nitrate over 55.6 liters. Now the difference between these two is right there, and it is huge. That was a poor way of doing that, ladies and gentlemen. The difference between these two is this is multiplication, this is equals. You do different math in multiplication and equals. Okay? But again, this whole molarity doesn't help me. I don't like that unit. I understand why people write it, but I don't like that unit because it doesn't tell me much. Instead, I'm going to write it this way. 0.050 moles of CuNO3 2 over 1 liter would be equal to X moles of CuNO3 2 over 55.6 liters. Now, you have created now a proportion here. What are we solving for? X. To get X alone on one side, what do I do? Multiply by what? I multiply by the 55.6. And what I do to one side, I will do to the other. Okay? Here, I did the same thing. 55.6 times this molarity. Now, to get this alone, I'm going to multiply this side by 55.6 and this side by 55.6. I'm going to end up with the same answer, ladies and gentlemen. It doesn't matter which way you do it, as long as you're doing your math correctly. But there is a big difference between a multiplication sign being in between two things and an equal sign. And you have to be careful to do the correct math. This is all just algebra. This is algebra. This is a problem where down here you have one variable and you need to solve for it. So we isolate our variable. I prefer to do this. I prefer to make this a conversion factor because then I can multiply it by this. And if I need to, I can flip this over. Why? Because conversion factors, I can put moles over formula mass, or I can put formula mass over a mole because they are equal to each other. This is saying that 0.050 moles of copper nitrate is equal to 1 liter of it. That's what we're saying here. Okay? Questions? Now, I did not finish this problem. Okay? This number still needs to get converted into mass. But again, we have done moles to mass about 1,000 times in here if you've done the practice problems. And you're going to take and you're going to find the mass of copper, 63.55 plus 2 times 14.0 plus 6 times 16, or 6 times 16, 96 plus 28.02, that's 124.02, plus the 63.55, that's 189.57. You use that to get 2 grams. Questions? By the way, please think about this. This is a very what kind of number? 0.050. Small. In the end, we should be in probably a fairly small amount of moles, but this is a pretty what number? That's a lot of liters, right? 55.6. So I guess that ends up, working against that small number that was up on top. Okay? But you got to have a kind of an idea of what your numbers are. Are they big? Are they small? Things like that. Questions? All right, clear your desks of everything except for your periodic table, something to write with, and a calculator, ladies and gentlemen. I do not use the term on here, ladies and gentlemen, but concentration and molarity are the same thing. Okay, concentration is molarity. How many moles are in how many liters? They are the same thing. Okay? I don't use that term on here, but just so you know. All right. Good luck, ladies and gentlemen. Please remember to show me all your work. Please remember to include your final answer with the correct units and the correct sig figs for full credit, ladies and gentlemen.
Wait, I thought it was six.
By the way, I'll give you another A.
Can I just go put that over?
I'm gonna make sure nobody's in there, so just hang on a second, but I think it's open, yes.
I don't think there is anything that I actually need to explain to you, ladies and gentlemen, as far as nothing special. Just make sure you are answering the question. What is it solving for? Moles, volume, molarity. Make sure it's in the correct sig figs and in the correct unit. So yeah, you're fine here.